Hello and welcome. My name is Inge Patsch, and I would love to welcome you to the series of complexity thinking. Today, an introduction into what is complexity thinking. I'm a big fan, or I'm a student of Sheen Bolton, Peter Allen, and Cliff Bowman, who have been writing this wonderful piece of work, Embracing Complexity, a book I can highly recommend you if you want to have a very practical, work-oriented guide, which is still looking into the academic fundamentals of the idea of complexity thinking. They would start off from a chapter about complexity thinking in history, so how there have been always cultures who adopted the complexity approach around, to why did we lose this viewpoint of complexity in the past. And it basically came back again mainly through chemistry and physical science, so through the natural science. Natural scientists were the first one to embrace complexity again, and meanwhile it has also reached out again to all kind of social science, be it economics or sociology, of being a relevant state-of-the-art type of research. So what is complexity thinking? I think in order to explain what is complexity thinking, I would like to explain what is it not. It is not this mechanical worldview which we have at the moment. So what do I mean when I talk about mechanical worldview? It's this idea that the planet and life and everything around us is basically a very, very complex machine. And if you're just like smart enough, we would understand this machine and all the bits and pieces, how would they work, and we could just figure out what it is. And this is if you just think about it for a second, you can pause the video here and think about it, but that's eventually what most of us have been taught in school, or we have been growing up with this idea that the world is a complex machine, and if you just learn to understand all the processes in there, for example, the brain and how does the different cycles function, we would just be able to control everything around us. So we're able to control weather and be able to control the climate if we just understand enough about the mechanics behind it, and we know where to twitch on which screw. This worldview goes back to someone called René Descartes, who was a very big thinker several centuries ago, and he was the one who coined also the statement cogito ergo sum, I think, therefore I am, which was a deep philosophical discussion and debate about what makes a being a being. And there is a story conveyed that he would even have students whom he would say to cut open dogs alive, and the dogs would scream out in pain, and he would say to them, "Oh, don't worry, these are not sentient beings. They don't have feeling. This is just the squeaking of the machine." So he was apparently in a very strong worldview that nothing besides one personally is really real, and everything is just a big, big machine to handle. And there are still many of these thoughts, like for most of the Western Europeans nowadays, I would say that the idea of emotion reaches as far as maybe humans and maybe a handful of pet dogs, but then beyond that, sentience is not really thought in comparison, for example, to let's say the Buddhist worldview, which would always see sentient beings in all the animals, but even in the plants, and which has also been confirmed by different research, meanwhile, that there is something, a reaction at least, no? So I think complexity is going beyond this mechanical worldview and saying, no, there is something which is more than just bits and pieces and screws, and we will never be able to divide this apart and analyze it till the last rest, because it's more complex, it's dynamic, there is not the machine-like thing, but there is more the life-like thing, there is this fluidity in it. So let me briefly talk you through 5 aspects or 5 characteristics which complexity worldview embraces. The first one, and this is the biggest overlapping point with systemic thinking, is that it looks into the systems, it sees the pattern, it understands the relation between things, items, nodes, persons, natural environment, and so on. So we could also say the sum is bigger than its parts. It's like this 1 + 1 is more than 2 idea, which is there of saying, okay, there is this complex webs of things which are connected with each other. There are feedback loops, there are balancing loops, all these aspects, and they make something which is systemic and more complex than, let's say, a linear take, make, dispose, or heals the offender type of approach to problems. A second aspect which complexity theory takes into consideration is saying that the situation which we are in is path dependent. So it's not in a way that you can say there is ever a tabula rasa moment. There is ever like this blank paper from which we start off. So everything where we are now is we're depending on the past. So also this means that a solution which might work for me might not work for someone of the same age, with the same gender and the same cultural background as I have, because we have gone different paths. Or also economic solutions which have been working for Europe or for Austria might not even work for Spain, not even to talk about maybe an African country, because all countries have gone very, very different historical background, and all these actors are still influencing what is happening. So you always have to be aware of the path, and there is also no return in complexity science. So it's not in a way that you could rewind the tape and come back, because yeah, you always have the history of something, so you can only go forward and never go back. A third aspect, which is very much related to the first one, which I was saying, is that complexity theory is always looking into being very sensitive to the context. So it's exactly the opposite of a one-size-fits-it-all approach. It's saying, dependent where on you are in the world, dependent on the exact household, the exact company, or even the particular individual, a solution might or might not work. So you always have to look into the context in which you're embedded, see the dynamics there, appreciate the dynamics there, and then accordingly act. Complexity thinking, and this is, I think, the part I like most about it, is there is this term emergent. Emerge means to just arise, come out. And it's this gray zone between, it's this in-between zone between being totally uncertain, so you don't know what could happen at all, while it's not random. So it's this gray zone of saying you cannot plan what will happen, but it's also not so random that you're totally surprised by what would happen. It's this idea of saying, you know that something would come, like we all know that the economic crisis would come up at a certain stage in time. Just no one knew what would trigger it and how exactly would happen. But it's uncertain how it will happen, when it will happen, to which extent it will happen. But it's not random, because we knew, for example, this crisis is about to come. So there is still patterns. There is still some kind of reoccurring moment, but it's not random, as I said. But it's also not fully plannable, and I think this is what was my biggest aha effect when it came to complexity science, saying no matter what we do, and no matter how many machines and computers and brain power we put into like modeling the future, we cannot plan it. Like, it's too complex in order to be able to be planned, which is one of the insights, which was my biggest insight when I learned about complexity theory at first. And the last one, and also this one I find beautifully to observe, and which gives me a lot of optimism, it's saying it's episodic. So change is not happening incrementally. It's not like you introduce something and then slowly change will happen. So I have another video where I talk about the 3 horizons, where there is this beautiful model of fading in and going out. But from complexity thinking, we can learn that like this can happen. It can be that change happens like this, but more often and more likely, there will be a certain dominant system, and then nothing will happen for really long, and then flip, and you will have a switch into a total different system. So we call this being episodic, that change is not happening incremental, step by step, but the change is happening all of a sudden. So it's also, the term tipping point is correlated with it, so you might have heard of this. Tipping point means that first you have a certain dominant regime, so you have a certain dominant context, system, the way it's working, what is dominant, who is doing what, and so on. And then you try to make interventions, and it seems nothing is happening, but probably you build build awareness among the community. A few leaders have heard about a different approach, and then switch. It can happen within a few days that the old system is overthrown and a full new system is in place. This can be for natural systems as well as for social systems, but we will talk about this in a different video. I hope this brief introduction into complexity thinking was a nice starting point for you, and I hope that I will see you again in another video.